Hello students, welcome to fourth lecture of Electrochemistry competitive. We already did the 3 lectures of the competitive earlier, so you can go and refer it and then you can continue with this fourth lecture. So in today's lecture we are going to discuss some questions and their solutions. First of all, we will go to the procedure how can we solve of certain type of questions, and then we will see some of the examples. So as we already observed this table earlier, standard electrode potentials of some species. So values are mentioned, and from this value we can identify cell output using any two of these given species, and we can also identify which of them will be oxidized and which of them will be reduced, or in other words we can say that which of them will be cathode and which of them will behave as anode. So we can also identify the sequence or series of oxidizing nature or reducing nature. So how can we do it? Let us use some examples and then we will try to solve some of the questions. So first of all, symbolic representation of standard reduction potentials. Suppose if you want to write for copper, then you have to write it like this. Standard electrode potential of copper is equal to 0.34. Now this symbol specifically represents reduction potential of copper. Now try to find difference in this symbol with this first example. So what is the difference between these two? In first example, it is reduction potential, standard reduction potential of copper. Then what is the value of second, and what is the difference between these two? So second one is standard oxidation potential. If reduction potential is plus 0.34, then oxidation potential of the same species will be minus 0.34. And how can you identify which of them is oxidation potential and which of them is reduction potential? From this symbol, as you can see, we are converting Cu2 plus into Cu. That means we are decreasing the oxidation state. And what about the second? Cu2 Cu2 plus. It represents we are oxidizing. Initial stage is Cu, that means it is our reactant, and final stage is Cu2 plus, that means it is our product. So it is oxidation reaction. We are increasing the oxidation state. So this value also represents oxidation potential. Okay, so first is standard reduction potential and second one is standard oxidation potential. So keep in mind, always watch these terms or symbolic representation first and then compare them. As for example, suppose we have a question like this. We have three different species X, Y and Z. So their potentials are mentioned here, 0.2, 0.3 and 0.4 respectively for X, Y and Z, and our target is to find their reduction agent strength. That means which of them we have to place them into decreasing order. That means highest reducing agent, then second highest and lowest reducing agent from these three. So first of all, we have to arrange them into their specific order of reduction potentials. But did you notice not all of them are reduction potentials? First one is reduction potential because it represents decrease in oxidation state, and the last one also represents decrease in oxidation state. So these two are reduction potentials, but center one represents it is oxidizing. Oxidation state is increasing. That means this value is for oxidation, or it is the oxidation potential. So that means reduction potential of this species will be minus 0.3. That means opposite of oxidation potential. Now you have to arrange them into their increasing order or decreasing order, whatever you want. So our target is to find strongest reducing agent and then least strongest reducing agent or weakest reducing agent. Now we know that these values actually represents strength of reduction of itself. If reduction potential is higher, that means our species will be reduced, and if our species is reduced, then it will behave as oxidizing agent. So you have to arrange them into decreasing order of the reduction potentials to find increasing order of oxidation reducing agent. That means first of all, let us arrange these three species into increasing order of their reduction potentials. So lowest reduction potential is for Y, then we have X, and then highest reduction potential for Z. Okay, so this is the increasing order of the reduction potentials. So that means X has a common nature to be oxidized and Z has common nature to be reduced. If Y is being oxidized, it will behave as reducing agent. So Y is the strongest reducing agent, then second one will be X, and then least reducing agent will be Y. So this is the reducing agent order, and oxidizing agent order will be opposite. Z will be strongest oxidizing agent, then X, and then Y. So that means if you want to find order of a reducing agent, you have to follow decreasing order of the reduction potentials, and if you want to find oxidizing agent order, then you have to follow same order as the reduction potentials. Okay, just notice reduction potential order and oxidation agent order, both of them are same. Now here is another example. So in this question we have two different values of reduction potentials of copper and for tin. So which of the following statement is correct if Cu2 plus to Cu is 0.337 and reduction potential of tin is minus 0.136 volts. So notice here for copper it is positive and for tin it is negative. So four options are mentioned. Cu2 plus ion can be reduced by H2, Cu can be oxidized by H plus, and Sn2 plus ions can be reduced by H2, and Cu can reduce Sn. So here we have four options, and in this case we have to arrange three different potentials for copper, for tin, and for hydrogen. So let us do it. So here are three values, and they are in order of decreasing reduction potential value. Highest reduction is for copper, then we have for hydrogen, then we have for Sn. Now first of all let us arrange them in order of their reduction strength. So in order of reduction strength, copper has higher tendency to reduce itself. That means it will be strongest oxidizing agent from all these three. So copper will always be reduced in presence of H and Sn because its reduction potential is highest, and it will always oxidize H and Sn because they have lower strength or lower attraction towards the electron because of lower value of reduction potential. So copper will be always reduced. Then we have hydrogen. If you have hydrogen attached with copper, then copper will be reduced, hydrogen will be oxidized, and we have tin later. Then H and Sn, if you attach these two, then hydrogen will be reduced and Sn or tin will be oxidized always. So this is their reduction order. Copper will be always reduced with H and Sn. Similarly, if you want to find oxidizing order, then oxidizing agent order will be opposite. Sn will always be oxidized, hydrogen will be reduced if you attach it with Sn, and copper will be reduced if you attach with hydrogen. Okay, so these are the orders. Now reduction will be always done for ions. That means we have Cu2 plus, H plus, and Sn2 plus, and oxidation will be done for atoms or molecules. That means Sn, H2 and Cu. So this is our order. If you attach Cu2 plus with H plus, then always electron will feel attraction towards the copper, and copper will be reduced always. That means whatever the situation is, copper will be always reduced with hydrogen and tin present with it, and tin will be always oxidized with hydrogen and copper, no matter what. And remaining for hydrogen, we can say that hydrogen will be always reduced with tin and it will be oxidized with copper. Okay, so this will be our order of arrangement. Now you can go back to the question and then try to solve the answer yourself. Here is a description. Okay, and if you still find it complicated, feel free to ask. You can ask me again and we can discuss it in detail. and try to solve the questions mentioned in reference books or in exercise, and try to find the related question to this point. And in next lecture we will attend some another difficult questions.